What we're going to do here is we're going to take two different proportional relationships and compare their unit rates. So let's go ahead and read the problem. It says the equation y equals 2.75x represents the rate in barrels per hour that oil is pumped from well A. The graph represents the rate that oil is pumped from well B, which well pumped oil at a faster rate. So we need to figure out what is the rate of well A, what is the rate of well B, and then finally decide which is larger, well A or well B. So let's start with well A because A comes before B in the alphabet. So well A has the equation, we are told y equals 2.75x. We know that this is a proportional relationship because, ooh, I don't know if you can hear that thunder outside, it's storming. We know that this is a proportional relationship because the value of b here, if this were y equals mx plus b, is 0. The way a normal human would say that is there's no number added after the x. So it's just 2.75x and not 2.75x plus 4 or something. So that's how we know it's proportional, which means we could make a table comparing y and x and then just do y divided by x to compare the values. And I'm just going to do a really short table. We don't need a really long table for a proportional relationship. In fact, we really just need to do a table that has one column, but we'll do a few just so you get the idea. So if the value of x was 1, we would have y equals 2.75 times 1, which is 2.75. If the value of x was 2, y would be 2.75 times 2, and that is 5.5, I think. Sure, 5.5. If the value of x was 3, we would have y equals 2.75 times 3, which is 8.25. And then finally, if x was 4, we would have y equals 2.75 times 4, which is going to be 11. And of course, since it's proportional, all of that after the one 2.75 was completely unnecessary because a proportional relationship, we can find the constant of proportionality, k, by doing any y over x. Just using the first one, 2.75 over 1 is definitely the easiest because 2.75 divided by 1 is 2.75. And we would get 2.75 if we divided any column. If we did 5.5 divided by 2 or 8.25 divided by 3, we get 2.75 every time. So for well A, the rate of change is, lordy, 2.75, I forgot what we were measuring, barrels per hour. 2.75 barrels per hour. I don't know if you can hear that thunder. I don't know if the mic is picking that up, but there is some powerful thunder going on right outside. Tiny little bit of rain, but mostly thunder. Golly, it is loud. You definitely can't see my dog is freaking out right here underneath this desk here. Not a fan. Not a fan of the thunder. All right. So let's take a look at well B. Now, well B does not give us a table or an equation. It gives us a graph. And so when we're given a graph, what we'd really like to do to find the rate of change is just to find rise over run. That would be the easiest thing. To find rise over run, we just need 2 points. And since it's proportional, we definitely want to use the easiest point of all, which is 0, 0. We can use any other point on this graph that we want. So we want to search for one that is at an intersection of the grid so that it's a really easy number for us to find. I like this one right here. That point looks like it is exactly on the intersection. And so let's count our rise over run. There we go. There's our rise over run. So get my pen a little smaller here so I can write. It looks like our rise is going to be 1, 2, 3, 4, 5. So rise equals 5. And our run then is 1, 2. So run equals 2. Okay, so the way that we find our slope, which is for all intents and purposes the same as our constant of proportionality, is by doing rise over run. So that is going to be, what do we say, 10? It's 10 over 2? Oh, let me back up. I counted 5. I counted 5 squares. But the reason I'm using 10, I hope you can see, is because even though there were 5 squares, the grid is going by 2s. So I'm going up to 10 on the Y. And then if I'm doing my run, I counted 2 squares on the run, but each square is not worth 1. If I look down here on the x-axis, I'm going 2, 4, 6, 8, 10. So my rise is 10 and my run is 4. So really I should be doing 10 over 4. That's actually what it is, 10 over 4, because the graph goes by 2s, but 10 over 4 reduces to 5/2. There we go. So I have a tiny, tiny little problem here, which is that the rate of change I have for well A is a decimal, 2.75, and the rate of change I have for well B is a fraction, 5/2, and I want them either to both be decimals or both be fractions. Either one is fine. I think it's easier to turn 5/2 into a decimal than to turn 2.75 into a fraction. So I'm going to just turn the 5/2 into 2.5. If you just on your calculator do 5 divided by 2, you get 2.5. So this rate of change for well B is 2.5 barrels per hour. And that means since well A is 2.75 and well B is 2.5, well A pumps oil slightly faster, pumps at 0.25, I'm going to abbreviate barrels per hour, except hour is not spelled with an O, Taylor, barrels per hour faster than well B. There we go. Well A pumps 0.25 barrels per hour faster than well B.